AlgoWeek. And so again, I am Gaurav. I am the lead for DSACP and I'll be the instructor today. We won't be teaching anything. We'll mostly cover some resources and other things. And I'll be assisted by Roshan today. So again, our LinkedIn, you can follow us on LinkedIn if you want. Moving on, this is what we will discuss today. So our first agenda would be learning resources, followed by where you can practice things. Next, we will see what are some common mistakes which people make when they start learning DSA or why they are not able to progress, followed by a simple study guide for you to follow. Then we'll also talk about the problem solving process about, let's say, if you get a problem on your own, then how should you do that? We don't want to depend too much on tutorials or AI agents. So it's better to know the process so that you can start dissecting problems on their own. And finally, we will have a quiz. All these 5 segments should not take more than 30 to 40 minutes, after which we will have our quiz. Again, we'll discuss the rules once we move on to that. So moving on, let me talk about a few resources. So these are 4 of the most popular resources, and these are industry standard. And to be specific, Strivers and LabBubbers DSA sheets are the most popular ones in India. Again, I have attached the links. We'll share the PPT. You can check all this out later on. So these are the 2 most popular sheets in India. There are other 2 sheets as well. Neat code for someone who wants to solve in Python or is ready for more tough challenges. And we also have Code Story with Mike. Yeah, so these are the 4 options which we have. So this is what you do. You don't pick problems randomly out of these. For example, if you're already in a position wherein you have solved some problems and you're stuck on specific questions, then you can watch specific videos if you're stuck for a very long time. Otherwise, these platforms will usually provide you a structured playlist for learning and improving your DSC skills. So yeah, again, check any one of these out, and whatever suits you, try to go with that. Moving on, Take You Forward. Now, Take You Forward is Stiver's platform. So this guy, he has a platform called as Take You Forward, where he has a DSA sheet. There are different kinds of sheet, a DSA sheet, ST sheet, etc. So for a complete beginner, I'll recommend the DSA sheet. For someone who is, okay with a little more compact roadmap, you can try the SD sheet. And if you are preparing for interviews, or if you are preparing for, revising whatever you have done, there are 2 other playlists as well. Again, all of this is on his website. I have added the link over here. You can check that out when you get the PPT. Now, he offers 2 types of services. Okay, so he goes for the paid one as well, wherein you pay, but he also has the free one. So majority of the people will go with the free one, and I would recommend that as well, because the paid one is around 6K. It's up to you if you want to get it or not, but I'm not advertising anyone or endorsing anyone. In case you want to learn DSA in a structured manner, both his free and paid resources are brilliant, and you'll get the video followed by the exact question as well as the solution to that, and code in 3 or 4 languages. I think C++, Java, JavaScript, and Python are the languages in which he covers his solutions. So in the resources shared, and he teaches using pseudocode. So yeah, this is that. And now we also have a Pareto problem set. This is quite popular as well. I have added the link over here. This basically classifies problems into different categories and gives you some a roadmap of sorts to start solving problems. And by the time you cover around 50 or more than that, you'll be at a good stage, and you'll be able to solve a lot of problems. You can try solving them on their own, as long as they are within the range of material you have covered, or maybe not an optimized solution, but you should be able to do something. So this is about the Pareto problem set. And again, there are a variety of other learning resources and websites. We have, we'll talk about that in the next slide, by the way. But yeah, these are the 2 most popular ones. So yes, moving on, these are practice platforms. So let's say you have learned DSA. Let's say you have learned some 3 concepts. Which concepts? Let's say you have learned arrays this time. You have learned binary search. Let's say you have also learned linear search. I mean, we did discuss it. So let's say you learn linear search as well. Now, if you have learned these they have a specific way of doing things. So binary search, you split and then you keep reducing your search space till you find the answer. Linear search, you keep searching till you find that answer. Now you know the pattern, but you also want to try out problems, because unless you solve problems, you won't know if you know the concept well or not. If you go to the heart of binary search, when they teach it in college or anywhere, the very basic form of binary search, it's usually about low, mid, low, high. You find the mid. If it is, not that answer is in the smaller side, you reject the high. You make mid equal to high minus one, or vice versa if it's on the higher side. And this is how you solve it. And if you don't find it, you return minus one. That is the most basic form of binary search. But over the last 2 days, we saw that you can also search binary search for optimization, and you can also use it for binary search on answers. Basically, you are given a number n and you want to find some value for which you can get an optimal solution. So again, unless you solve problems, you won't know how to what are the capabilities of such techniques. So these are the different problems. Of course, in Striver's playlists and even the Pareto problem set, they mostly cover questions from Lead Code and Geeks for Geeks. So Lead Code is the primary platform which you can take for practicing questions. Again, why? Because we have added the link over here, because when you go Lead Code, you'll find more than 3,700 problems. I'll also show the interface, how things are there on all of these 4 platforms in a while. And yeah, so Geeks for Geeks, again, this is a learning resource as well. You can find materials on all other subjects as well, not just TSA. And they also have their own ID in case you want to practice competitive programming, or in case you just want to learn DSA. So Geeks for Geeks is a good option. Now, what about Code Forces and Code Chef? Code Forces and Code Chef is, it caters more towards the competitive programming audience. So Code Forces, by the way, has a very large problem set. They have a lot of contests. They have like both Code Chef and Code Forces will have contests every Wednesday. They also have some other contests as well. Same, Lead Code has a contest every Sunday in the morning, and on a bi-weekly basis, they have one contest on Saturday evenings as well. Geeks for Geeks, they do have a contest. I'm not sure about the exact timings. You can check these platforms out about the exact contest details. Now, about these 2 platforms, in case you want to practice, more challenging problems. You can get easier problems as well. If you want to go for more challenging edge cases, the question looks simple, but it breaks your code quite often. And you can try out these 2 platforms, and you can try out the contests. So this is about the practice platforms. Just give me 1 second. I will also show a few of the resources. 1 second. Okay, so let me discuss, let's say, codechef.com. If I go to this website, and so this is the interface. You can check this website out later on. There are a variety of courses and learning paths as well. But let's say if I just go for practicing, I can practice a variety of topics. So let's say I go for data structures. Now there are different categories of questions. So there are rating difficulties. So yeah, this is one thing which you can check out later on about competitive programming. Problems are classified into the rating categories, kind of like chess. The higher the rating, the more difficult your problems. So let's say if I go for 1000 to 1400 category. So these are a few problems. You can try them out. Let's say if I open this one. So this will open something, and I'll see a problem over here. I can type things over here. You'll have to create an account and log in for the to run the code. I think I'm not sure exactly, but yes. So this is how things would look if you practice something on Code Forces, Code Chef. Again, if I talk about Code Forces, just give me 1 second. Yes, so this is Code Forces. Code Forces, the UI is not all that good, but this is a fantastic platform in case you want to practice competitive programming. Again, this is a very fun platform as well. If you go through the charts and the kind of blogs which they have, it's very interesting. So if you go to the problem set section, you can see a variety of problems. Again, the best way to go through Code Forces problems is through a ladder like structure. So you can reach out to us later on in case you are interested about the ladder structure which I'm mentioning right now. Otherwise, you can simply check questions based on their rating. And yeah, so this is how you would solve problems. And if I go by rating, you can see different people over here with the different. In fact, if you are this person, then you're at the top of the world when it comes to DSA and CP. Anyway, moving on. So we'll talk Geeks for Geeks about Geeks for Geeks. Okay. There's some different link. Okay. It's on .com. Yes, this is Geeks for Geeks. Again, they have different. Let's not go to courses. Let's go to practice. Let's go to practice DSA problems. So there are languages which you can pick from. Let's say if I go for sorting, which is a text, I can find a variety of problems. I can try solving them step by step, or I can hand questions selectively and then start doing them. Again, better to go in a structured format. So this is about GFG. The final platform, the one which we have used so far to code, is Lead Code as the industry standard when it comes to preparation for placements, as well as getting good with DSA. So if I go over here and if I write problem set, this will take over there. And so this is login. And okay, so let's say you want to solve questions on that, expand that, and you come to arrays. And so you come over here, and what you do next is you'll see these are the questions which you have. So click on sorted and enable tags. This will list the tags associated with them. So for example, you might think that, okay, this question, let's say, this question is using arrays, permutation through arrays along with backtracking. So like this is tagged under this thing. So this helps you out in sorting questions based on the only concepts. So for example, if you're comfortable with hash table and array, out this one. Not saying you cannot solve a question which is stacked with array and backtracking both with just one technique. It depends upon the kind of question you have. Yeah, so this is one thing which you do. Another thing which you can do is you can filter things out based on this difficulty, etc. I generally don't use this one. Moving add acceptance rates of this too. And so if you add acceptance of the solution submitted, 94.8% accepted. On the other hand, if I go at the very, if you keep continuing, that acceptance drops. This means that this problem was only accepted 79.5% time for the solutions. One more thing, this lock means it's a premium problem. Don't worry about that. Most of the problems are free. So that shouldn't be much of a concern. You can shuffle problems, so randomly pick something. I got maybe, because that goes beyond our means right now. Again, there are a lot of options. You can filter out, and you can let's say I only want to do medium questions. So this, and now I'll only get medium questions over there. I guess this makes the point clear, right? Guys, are you clear about the practice problems and how they look like? If so, please type in the chat. Won't continue unless you type something. Okay, so we'll move on with the presentation. Give me 1 second. Okay, so this was about these platforms. Now, what are some common mistakes failed solving DSA or DSA related problems? Lack of concept clarity. So let's say you want to solve a problem on binary search. So let's say you have a question on binary search and answers, but you're not clear about what does binary search have to do with on answers. For example, that SQRT experiment from yesterday, you are not clear about the parameters. Okay, so let's say you are using binary search over here, but you are not clear about what kind of parameters does binary search accept, or the specific technique use. So this is one reason why you might not be able to solve a problem. It's better to go through the concept, the basics of it, and understand those before trying out problems on that. Next thing is inability to visualize. Yeah. So what happens is, let's say my question is kind of tricky. So my question kind of uses, let's say it uses an array, and again, let's say it uses a two-dimensional array. Okay. So it uses a two-dimensional array like this, and let's say 0, 1, 2, 3, 4, 5, 6. My question was like this, and I was supposed to find the transpose. So again, how would this look? 0, 1, 2, 3, 4, 5, 6, 7. So this should have looked like this. I was not able to visualize the situations. Okay, if it's a square matrix, I don't have to alter the number of rows. Number of rows is equal to number of columns is equal to n. But in this situation, number of rows and number of columns is not the same. This will be the number of columns, and this will be the number of rows if you take the same word. So inability to visualize situations like this, what can happen, is one reason why you might not be able to solve a problem. This is a very rudimentary explanation. There are problems which are very easy. It's just that the way in which it is framed is difficult. You might have seen it in one of the problems from yesterday, which was the candy distribution problem. The question was pretty easy. So go in a structured way. First, you'll learn the basics, and then you'll learn sorting, followed by arrays, and so on. And then you'll move on eventually stacks, queues, followed by, let's say, trees, so on, until you move on to DP, and then very advanced algorithms. So if you don't follow this structured path, unless you randomly pick a problem which was on DP, and this problem, I mean, you could try to come up with a solution using just basics of arrays, but let's say lead code doesn't accept it because it is not. In such a situation, you could have a problem. So don't pick questions which are beyond your means. Try to go step by step. By the time you reach DP, you would find that all the problems from before that are a little easier. So this is something that you should do. One thing is jumping to solutions too frequently. So if you're not able to solve a problem and you're jumping to solutions too frequently, let's say you see a problem, you read it, and in the first go, you're not getting a mental image of what you should do or what does this even mean. It doesn't mean you should jump to your solution immediately. Try to read it 3 to 4 times. Try to take time. Let's say you read it this time, it's not making sense. Look at it again after, let's say, 1 hour or 1 day. Again, not for too long. So yeah, don't jump to solutions too frequently or hints too frequently. You should give some amount of time. We'll talk about time as well. Not revising past problems. It's kind of like your normal studies. I have moved on to, let's say, I have studied up till trees, but there were certain concepts. Let's say that I studied recursion before, and recursion is heavily used in trees. So I forgot some part about recursion. For example, let's say stack space, how stack space can be a problem if I have constrained memory, or if I have boundaries, how to stay within those boundaries while using recursion. So in such a situation, I should know about my previous content. So keep revising. Not every day you can have a schedule about, let's say, I'll revise the week's content on every Sunday, and once in a month I'll take, let's say, 2-3 days to revise all the concepts I've covered till then. How can you revise? You can simply go through your material and try to execute the same problems. You can try executing problems which you had difficulty executing in the past, or you can try solving similar problems to what you have learned earlier. Now, the next one is finally inability to convert logic to code. Let's say you came up with you saw a question, you came up with some logic, well and good, but you wrote the algorithm, not the algorithm, you found a specific idea that, okay, this is how I'll break it down and this is how I'll solve it, but you're not able to convert that to code. This is not good, because when you are submitting problems, you need to have clarity about what to code. This can vary based on the languages. For example, if I talk about pointers are there in C, but other languages like Java and Python, they don't have pointers. So you can have problems like this. So you need to know DSA enough, and your programming language enough as well. So yeah, this should be one of the reasons why you are not able to solve problems. Regarding the study guide, as and follow a structured learning process. We mentioned a few resources websites as well. Pick whichever suits you the best. Periodically revise whatever you have covered. And now this is more important. You will see people on LinkedIn telling I have done 500 problems, I have done 1000 problems, I have done, let's say, 200 problems. Now, this is good because by the time you covered, let's say, 500 or 1000 problems, you'll be at a stage where you have, solved so many questions that you have prepared enough. But does this mean anything? Let's say this 500 problems, 300 were very, very simple questions, which I could have done without much trouble. This is user. And if I had done, like, let's say on this 200, if I had done only 50 quality problems from the next set of concepts, or the ones which I have already covered, that would have been better. So don't chase quantity. Quantity is required, but more than that, you should chase quality. The quality of problem should matter more than your quantity. So let's say you learn a good problem, and then you try to do 3 to 5 problems based on that topic, or using those qualities, and then you can move on to the next topic. Again, depends upon how much time you have. Allocating time, again, I'll discuss this now. Don't jump to hints or solutions very quickly. As I mentioned, give it some time, because this is a part of fourth point. I'll discuss this. And yeah, sixth point is this: the inability to convert your logic to code mostly happens because you don't know the language well enough. If I talk about, let's say, C++, and you mentioned that I want to learn C++, C++ is a very vast language. You cannot learn everything in C++. There are a variety of concepts. There's multi-threading, and there is inheritance, there's object-oriented programming. So there are a variety of things. You don't have to learn everything, just know enough for you to code. If you are following this structured part, they'll usually cover it in any of the languages which you prefer. So it's usually, learn the basics of C++, like for loops, and then functions, and then arrays and stuff like that. Arrays as in the structure of an array, followed by STL, which is your standard template libraries, which contains some functions, for example, dot sort function, etc., which can make your life easier if you're writing more complex code. And so this is about learning any language. And finally, about allocation of time. So this is important. We have 3 categories of questions primarily on lead code. We have easy, medium, and we have hard. Now, depending upon what kind of problem you're having while not solving, you should decide how much time you're attributing. So let's say this is what I do: 30 minutes for an easy problem, 45 minutes for a medium problem, and 60 minutes for a hard problem. Beyond this, if I'm not able to solve this problem, I will not break my head on trying to get it to work. Now, again, sometimes you can solve your problem partially, well and good. Eventually, with time, as you solve more problems, you'll get things, how to do things. So if, let's say, now again, your problems could be your solution could be brute force or optimal. What is brute force? It means it's the most, it just gets the thing to work. What is optimal? It means this is the best possible way, which takes the least amount of time and resource to solve your problem. So if you are not able to solve anything within this time frame for that specific difficulty, you can move on to checking the editorial or the solution. In case, let's say, within those 30 minutes, let's say in 15 minutes, you were able to code the solution for the easy problem, and that wasn't brute force. So you can try optimizing that solution. Again, this is completely on you. If you know that the optimal solution for this uses an advanced algorithm, for example, DP. So, in such a situation, and you don't know DP, in such a situation, you can, after those 15 minutes, you can move on to the editorial for the optimal one. But in case you have the time and you can somehow do something, you should spend those 15 minutes to solve this. This is what I do. You don't have to follow this hard and fast, but try this out in case you want to give more time. At times, I have given more than 7 days to solve a problem if I feel like I can do this, but I don't want to see the editorial. Again, it depends upon your commitments and time. Moving on about the problem solving process. So these are the 4-step process for solving any problem which you have. Whenever you have a problem, first understand the problem and its constraints. You might have remembered this, but on the very first day, I gave a question and then I broke it down into what the question was mentioning, what does it ask for, followed by I mentioned what were the constraints. And after the constraints, I gave a step-by-step logic. So after you understand the problem well and good, you can break it down into different chunks, the problem. You don't have to try to deal with everything at once. After you do that, try to build a logic to solve that problem. You might have seen that algorithm from the first day or on the other days as well. where we discuss the steps to do. For example, read, process, write, and now within process, add some steps. Do that. After you have developed your logic, the next step is to code it, obviously, so that you can run it on your compiler and see if your test cases are passing. And if this is working, then okay, well and good, you have done the first successful thing, which is getting your problem solved. Now, let's say your problem is not getting accepted, the solution. This could be why. This could be because you are exceeding the constraint limits, for example, time limit or memory limit. And another reason could be because you are using a technique which your problem prohibits. So for example, you'll find this famous question on lead code: median of two sorted arrays. And this question mentions that you should not be using a merge sort kind of technique wherein you merge the things. You should use binary search to solve it. So I mean, the solution will be accepted, but again, you are not following the correct technique. So once you have this part sorted out, you should try to move on and optimize your logic for better performance. This is how you learn. Again, as I mentioned, if this doesn't hit you how to optimize, you can try watching the editorial within the given limits. Don't jump to editorial every time. Again, this note, you can use AI tools for the problems. Initially when you start, it's difficult, we understand, and so you can try to give your problem to AI and don't ask your AI to explain that problem to you. Try to talk with that AI. So let's say you pass a problem about SQRTX, and then you ask your AI tool that I'll give my reasoning to you, talk to me. How is this working out? So you keep talking to that tool and try that problem, and this is how you reach a problem breakdown. And once you have done that, you maybe try to come up with the logic, and at that point, let's say you try to check for cases, and you'll see that this failed somewhere. So you can use it for debugging. Mostly in questions on recursion, it's difficult to debug manually. So what people will do is that they will put their algorithm or their code, and they'll give a test case, and they'll mention, okay, debug this, and they'll not ask for pointing out what is going wrong. They'll just check and try to understand, okay, this is happening, and this is okay, this looks wrong. Again, this is not recommended in the long run because it develops dependence. This should only be used as a tool for getting started. Depend on AI tools altogether for solving your problems.